This is the Math 1113 Zoom meeting for March 2nd, for Tuesday, March 2nd. Section 6.2 this week, practice problems, page 518. These problems for practice, pick these sections out. Quiz this week based on these problems. Quiz is available Friday and due Sunday. For web assigned problems this week, personal study plan, problems 1, 2, 6, and 7 only. There'll be a practice, personal study plan and the practice quiz. And then email me the percent of these 4 problems that you get correct. Six point 2 has a repeat. Pretty much a repeat of 6.1 identities. They show this on page 511 at the bottom. Wi-Fi's got a bit of a delay here. Get it where you can see the whole box. Okay, so you can kind of see Y is a sine of an angle, T is the angle around, Y, the sine of an angle. They're using T as a number because they're treating sine as a function, but it's the same concept. Chapter 5, they call this a theta. Here they call it a T for a number. The sine of it gives you the Y coordinate, the cosine of it gives you the X coordinate, the tangent gives you the ratio. Cosecant is the flip of the sine, cosine, or secant is the flip of the cosine, and cotangent, cotangent is the flip of the tangent. Okay, so I'm going to flip them this way. Y is equal to sine of t. This is again for on the circle, t there for the angle, coordinate X and Y. The Y coordinate is the sine of the angle in around. The X coordinate is the cosine. Y over the X gives you the tangent. 1 over Y gives you the cosecant. 1 over X gives you the secant. And X over Y gives you the cotangent. And you can almost see the formulas. They give you again the special angles. I don't see any real point writing them all down. Hopefully you know them, they don't change. You switch it from T to theta. But you can see at pi over 6, your cosine's root 3 over 2. Your cosecant 2 flip over secant flips around 2 root 3 over 3. Your cotangent's root 3. At pi over 4, both sine and cosine are root 2 over 2. And at pi over 3, you can see the values you get. I think the circular thing here is much more understandable. You start off at 1, 0. We've written this down several times. At pi over 6, your long is the x because you're pretty shallow. Half at pi over 3, it flips. And at pi over 4, your legs are equal at root 2 over 2. At pi over 2, you're up to 0, 1. And at 0, you're at 1 and 0. Okay. So then they talk about domains. Sine and cosine, it's all real numbers. Tangent and secant, it's all real numbers other than pi over 2. And cotangent, it's all real numbers other than multiples of pi. Okay, and they repeat the signs of the trigs. So they're showing here which trig functions are positive. All of them. Sine's positive because it's y, so the x and tangent be negative. Tangent's positive down here because your sine and cosine are both negative. Divide them out, it turns positive. Cosine's positive because that's the x coordinate positive there. All right, and so they go on and repeat a lot of the same problems. There's example 2, I'm missing example 1 here. Okay, so just to try example 1 again, page 512, part A. T equals pi over 3. Find your 6 trig functions. Give you a diagram. Pi over 3 is equal to 60 degrees. And your base coordinates, you're over a half, you're up root 3 over 2. So if we do them in the standard table you're used to, a sine over 3 is equal to root 3 over 2. The y coordinate equals the y coordinate. Your cosine of pi over 3 is equal to your x coordinate. X coordinate a half. Your tangent of pi over 3 is equal to y over x. So that means root 3 over 2 over 1/2, which means root 3 over 2 times 2 over 1. 2's cancel, you're equal to root 3. Cosecant pi over 3, 2 over root 3, it's 1 over y. So if I go 1 over this, it flips around. You rationalize it. 2 root 3 over 3. Your secant of pi over 3, 1 over x, is equal to 2. You don't have to write it over 1. And your cotangent of pi over 3, 1 over root 3, flips the tangent, root 3 over root 3, root 3 over 3. Okay, so this is a lot of repeat. Why they feel compelled to teach it to this way with all the repeats, I don't know, but they do. Later in the chapter, there'll be some new stuff because you can treat them as functions, but at the beginning, they're repeating a lot. Now, if you look at example 2, part A, find a cosine of 2 pi over 3. So what we do is we locate 2 pi over 3 and write down the x coordinate. Why the x coordinate? Because it's a cosine. Well, 2 pi over 3 is into the second quadrant with a reference of pi over 3. That means your x is going to be negative a half, but your y will still be root 3 over 2. The x coordinate here then is negative a half. A cosine, here's my answer. My cosine of 2 pi over 3 will be negative a half. The calculator will tell me negative 0.5. Just to radian mode. Let's see what mode I'm in. degree mode, radian mode, cosine 2 divided by 3, negative 0.5. Declare off. Yep. There you are, negative 0.5. All right, how about one like C? The sine of 19 pi over 4. It's probably going to be something root 2 over 2, but what quadrant is this in? Is it positive? Is it negative? I'm dying to know. The suspense must be killing me. It must be killing you too. All right, well, let's see. This is 1 pi over 4. You're at 0. All right, if you come, let's see, trying to locate 19 pi over 4. You know, there's little tricks to do it. If you remember, you're at 2 pi here, which is 8 pi over 4. So, and you're at pi here, you're at 4 pi over 4. Add 2 pi, but you're at 12 pi over 4 here. Keep going back and forth. Add another 8 pi over 4, and you'd be at 20 pi over 4. Meaning you're at pi, you're at 3 pi, and now you're at 5 pi. All right, but that's 1 pi over 4 bigger than 19 pi, so you'd be second quadrant. And your sine would equal sine of 19 pi over 4 would equal a positive root 2 over 2. And the calculator would give you the decimal for that. Okay. Let's see. They start giving you the formulas, based on these. They give you more identities. Your cosecant would be 1. If y is sine, your cosecant is going to be 1 over sine. Your secant is going to be 1 over cosine. The Wi-Fi catch up. Secant will be 1 over cosine, and your cotangent will be 1 over tangent. Write those down, page 516. Cosecant t would be 1 over sine of t. Remember, this is y directly, so you're 1 over y. Just let it catch up. Your secant of t, 1 over cosine of t. And this is how you compute a secant or a cosecant. You go 1 over these functions. See, this is x, so you're 1 over x. Cotangent t, t is equal to 1 over tangent t. So they repeat them again. They just, can you plagiarize yourself? So here's the first place they give them to you. The Wi-Fi will catch up. And here's the second place. You have all 3 of them again, the first 3 over here, if it'll catch up. Let me speed up a little bit. Tangent is a sine over cosine, that's y over x. Cotangent is x over y, cosine over sine. And I gave you all a full video explaining where these come from. They're repeats. Chapter 5, they used a theta. Here they're using a t. Okay, they are doing one thing new here. Bottom of page 516. Here is something new. Even, odd properties. Okay. Let's see if you remember college algebra. Even versus odd. Okay. Even function. Example, x squared. Hope you remember it looks like this. Okay, it means if I come over here with an x, and I go up in f of x, it's getting worse. All right, well then I come over here with a minus x, same distance, and I go up and I have f of minus x, it's vertical distance. F of x is even if f of x equals f of minus x. Let it catch up. Practically means that you can ignore that minus sign. Now, I could show this with graphs. We're going to apply this to trig functions, and I could show this with graphs, but they haven't shown you the graphs yet. So we're just going to do it with numbers. Basically, like with numbers, what this means is if I put in a 3, x is 3, then up here I get 9. Let it catch up. Yeah, I'll let y'all see that. Okay. So if I use this negative number over here, let's say negative 3, on x squared, I still get 9, meaning f of 3 is 9, f of negative 3 is also 9. So if I get the same number out, f of x is even when I switch sign on the input. Let everything catch up. Trying to bring up so you can read what's there in the corner. There it comes. Still not high enough. Okay. All right, let's do the odd case. F of x is odd. Do x cubed. Side up, one side down. Pick an x. Pick a negative x. This is f of x. This is f of negative x. F of x is odd if f of x is negative f of negative x. Or you can write this f of negative x equals negative f of x, meaning you put the negative on the other side, and in effect this comes out. I said that really fast, so we'll let the Wi-Fi catch up. I almost make commentary on my own writing. So you got the same distance left and right. The vertical is f of x. Down here it's vertical, but it's down because one side's up, one side's down. All right, so I'm trying to say f of x is odd if you have f of x is negative f of x, and in effect, your negative sign comes out. All right, with numbers, and that's how we're going to show it with trig. Let's say I have 2. Well, 2 cubed is 8. So let's over here, let's say I have a negative 2, and I would get a negative 8. So I have f of 2 is 8. That'll go off here. And I switch sign on the input. Switch input sign. And I get out negative 8. And so I get the identical number, but the sign is switched. Sign is switched. Let the Wi-Fi catch up. So that's the two cases, even versus odd. We'll show you this. And the thing, instead of using graphs, you could use graphs and get graphs if you know what the graphs are. Basically, even, both sides are up, and odd, one side's up, one side's down. There we are. But I'll just do it with numbers. Any luck, it'll look easier. And speaking of repeating, These problems look familiar? He's having you repeat the coordinates. Let the Wi-Fi catch up. Okay, 3 and 4, I hope look familiar. They're repeats of last section, writing down coordinates at pi over 4 increments and writing down coordinates at pi over 6 increments. I won't repeat it. It's absolutely identical. As you do it again, something magical about changing that theta to a t. If I get those on the picture or not. See if the Wi-Fi will catch up. Doesn't want to catch up. There it goes. Okay. We're about 30 seconds behind now. Let's move it up a little bit. Yeah. So I won't repeat these. It's absolutely identical. The last section, root 2 over 2, negative root 2 over 2, negative root 2 over 2, then root 2 over 2, positive up. Just a repeat. Okay, just try a few other examples. I believe we'll work in 5. Let me get my assignment back here. 5 to 21. So let's say page 519, problem 5, part A, assign 7 pi over 6. Probably shouldn't have to do too many of these. 6 pi over 6. 7. Hope this is getting a lot more familiar to you. 7 pi over 6, be 1 pi over 6 bigger as your reference. Y coordinate would be down a half. Your x coordinate would be negative root 3 over 2, and your y coordinate would be down negative a half. Just put that up, show the picture. I don't know how many of these I bore you into doing. Let's see. 23 can look a little weird, but I'll let this catch up. The paper will raise. You can see the diagram. Okay, how about 23? T equals 0. Write the 6 trig functions. Diagram over here. T is 0, and your coordinates there are 1 and 0. This is almost so easy it's hard, but it looks a little weird, so I'll just try to remind you what you do with 0. find the, can't see that, can you? Okay, there we go. All right. So that's of course your x, that's of course your y. If I use the same standard table, the sine of t, actually, since they gave me 0, the sine of 0 is 0. Slower and slower. Yeah, made it a 0. 0. 30 seconds from now, you're going to see I write in the cosine of 0 is then 1 for the x coordinate. Your tangent of 0, I'll just go ahead and write them all down. And you can see the tangent of 0 is 0 over 1, which would be just 0. Your cosecant of 0 would be 1 over 0. Hope you remember that's undefined. Your secant of 0 will be 1 over 1. That doesn't change. It's identical. Secant's identical to your cosine. Okay, now I'm about to write it all out. I could make the commentary on the stuff as I'm writing it again. And your cotangent of 0 would again be 1 over 0, which would be undefined. All right, so I've written down the tangent. The cosecant of 0 is then 1 over 0, 1 over sine of 0, which is undefined. Y'all remember, secant of 0 is 1 over cosine is 1 over 1. So it's going to be identical. Flip 1, you still get 1. And finally, your cotangent of 0 will be 1 over the tangent, 1 over 0, which is undefined. Okay, so not everything is root 3's over 2's and root 2's over 2's and etc. All right, one last little section, 63 to 69. Again, they give you clues, 63 to 77, actually. We'll try 63. Page 520. Sine of t, -4/5. Terminal point of t in quadrant 4. I'll draw the picture, then pause. Quadrant 4. Sine is opposite. Hypotenuse would be 5. Can you tell that that's 3? 25 minus 16 is 9. Square root of 9 is 3. It's positive because it's first quadrant in x. So I'll pause, let the Wi-Fi catch up. T in quadrant 4. I'm kind of behind my picture. Don't know, I still have my picture up. Maybe I can stop the video and you can see, yeah. Okay. All right, they just want you to write your 6 trig functions. So you're given your sine of t, -4/5. Your cosecant of t, -5/4. Again, you can keep the negative on top, both of them. Your cosine of t would be 3/5, adjacent over hypotenuse. Your secant of t, 5/3. Maybe I should let the Wi-Fi catch up. So I've written down the sine of t there, -4/5. Cosecant of t is -5/4. Flips it. cosine of t, 3/5, secant of t, 5/3. All right, so I've caught up. Tangent of t would be -4/3. Opposite over adjacent. Cotangent of t, flip that, -3/4. Okay. Hopefully that's enough to get everybody started. Friday Zoom meeting at 10 o'clock. If anybody watched this far deep into it, Friday Zoom meeting, 10 a.m. I can take my son to school. I get on the picture. Okay, so I hope this is enough to get y'all started. We'll end the meeting and post the Zoom. See you on Friday if anybody comes out.